Can everyone hear me? Welcome. Should we get started? Let's do it. Welcome, everyone. Click. Yes. Hi, my name is Daniel Roth. I'm a senior program manager on the ASP.NET team. And today we're going to be talking about building services for mobile applications, websites, modern apps using ASP.NET Web API. Specifically, the latest, greatest ASP.NET Web API version 2 that we are just previewed this week. You should go and try it out. The title says web services. I actually come from a WCF background myself, so I don't know about you. When I hear web services, I tend to assume certain things, so I didn't want there to be any confusion. This is not really about web services in the SOAP sense. This is about HTTP services. We're going to build services using the HTTP protocol as an application-level protocol as it was intended to be used. And there are really good reasons for doing that. If your goal is to hit all these clients, to have your application be as broadly available as you possibly can, then you're going to need to speak a language that those clients speak. And one of the things that all these clients don't have in common, browsers, mobile devices, phones, tablets, set-top boxes, your car, your refrigerator, whatever, one of the things they don't have in common is they don't all have a great SOAP stack. But they do speak HTTP. If you get all those clients, you're going to want to be able to scale. Azure and the cloud gives you unprecedented access to scalable infrastructure, but you need to still make your app actually scale with that infrastructure. The REST as an architectural style has been given a lot of attention as a way to achieve scale, because it's basically the way the web scales. And lastly, you probably want to keep things simple. Let's not add extra layers where you don't need them. Let's try and avoid ceremony, extra configuration where it's not necessary. Let's try and keep things as minimal as possible, as just to get the job done. And that's what ASP.NET Web API is all about. It is a framework to help you build HTTP services. It's not really web services in the traditional sense. Like, you're not going to be building services over TCP or UDP over using SOAP. It's about HTTP services. HTTP is a first-class concept in ASP.NET Web API. You will see things like headers and status codes and response bodies in different formats and media types, and that's intentional, because those are the things you want to have your hands on directly when you're building HTTP services. Oh, and by the way, we're shipping a new version. That's what this talk is all about. All right, so how do you get ASP.NET Web API, specifically the new bits? Our bits ship on NuGet. You can get them right now. You can get them in your existing version of Visual Studio. You can install them into a project and get going. The bits are also available inside of the new previewed version of Visual Studio 2013. Their bits are there, but there's also additional features and enhancements that we've also shipped out of band that you can install on top of that preview. That's the ASP.NET and Web Tools 2013 preview refresh. You can get that off of the ASP.NET site at /vnext. That just adds some additional things. If you're going to play around with this stuff, I encourage you to make sure you get those additional bits as well. ASP.NET Web API 2 has taken a new framework dependency. The previous version worked on version 4 and above. We have decided to move on to 4.5. We get a lot of nice benefits out of that. We get to take advantage of the async stuff in 4.5, the task model using sync and await and so forth. We have done that, so it is 4.5 and above. And if you want to follow our progress, hopefully, actually, if you're in the know, most of the stuff that I'm going to present to you shouldn't be that new. It's not like I'm actually announcing something, because our whole project is open source. If you want to see what our devs check in up to the minute, just go to our Codeplex site. You can watch them check in. You can grab nightly signed builds. You can play around with the bits today, of course, that we're previewing officially on the NuGet feed. But if you want to try stuff that we're working on, for the next turn of the crank of this release, you can go try a nightly build and see what how the features are shaping up. And if you don't like it, feel free to contribute and fix things, make things better, because we absolutely accept contributions. Some of the biggest features in this release that we are shipping actually came from folks like you, from community members that contributed features to the core runtime, which is great. We really appreciate that, and try and call them out as we get to those features. All right, so let's get started. Let's build a web API. Let's see what it's like. Let's get our hands a little bit dirty. our first Web API with Web API 2. OK, I've got here Visual Studio 2013 preview. I've installed the ASP.NET and Web Tools 2013 preview refresh. So I've got all the latest, greatest goodness on top of this thing. And I want to create a Web API. So I'm going to do File, New Project. And I'm going to select the Web node inside of that left-hand pane. And you'll notice that the number of templates for web applications has kind of gone down. Like it used to be, there was MVC3 and MVC4 and web forms and this and that. And there was a whole laundry list of things. And you looked at it and said, oh, which one do I pick? The way the experience is structured now is you first say, I just want to create a web app. I'm not sure maybe necessarily exactly which pivot I want to go down. I may want to use multiple things, but I do know that I want to create a web app. So let's create a web app. Have I already created my first web API? Let's see. Sometimes I've already created it. Oh, I haven't yet. OK, good. All right. And you'll get put into a dialogue-like experience that lays all the options out for you in hopefully a more understandable way. We have a set of templates up here at the top. These are sort of starting points. You can think of almost like sample applications. Like if you want to start with an MVC style thing or web forms. But once you make that choice, you're not stuck with that technology. You'll notice down here there are these checkboxes. You can feel free to roll in some web forms and some MVC, some web API into any of your project templates. They all are meant to work together. This is what we call one ASP.NET, and this is the one ASP.NET experience. You'll notice that you can also choose to add unit test projects to your application. I'm going to go ahead and do that because I think I'm going to use that later. You'll also notice that there is some authentication configuration options here. If I select MVC, there's actually quite a bit of stuff that you can do here. You can use individual accounts. You can use your organizational accounts, all sorts of cool stuff. For Web API, we don't have that tooling wired up yet. We are working on it. We will have a bunch of security features that are actually built into this tooling experience. Didn't make it for this preview. We will have it soon. I will show, though, some of the security features, the runtime features that we are working on and how they're looking. All right, let's create one. So create a Web API. And this is where we're creating the project template, and we're going and installing all those NuGet packages, the Web API NuGet packages and associated NuGet packages, so that you can have a full and rich template experience. There we go. I'm going to go ahead and run that. And what this is going to do, it's going to pop up the browser. And we do throw in, normally HTTP services, they're mostly about data, right? They're intended for programmatic consumption. But we do throw a little HTML into this project just to give you some links. So if you want to know where our docs are, how to get more stuff, you can find out on this page. You'll notice that the styling of this page has been updated for this release. It's using Twitter's Bootstrap styling, which is very nice. It makes for a very dynamic looking and type web page. It scales very nicely. It looks pretty good. OK, and if I click on this API link which we provide, I get a really ghetto 1980s looking help page. That's because when we updated the styling for Twitter Bootstrap, unfortunately we broke the styling on the help page. We will be fixing that. It will not look like this in the final release. But the nice thing that you see here is I get a view of the surface area of my web API. I can see what it looks like. I can see what the URIs are. Oh, it looks like there's a web API that I can send a GET request to API/values or a specific value. I can add values and so forth. Well, let's try that. So I'll do, I'll just send a request in the browser, and it's going to open up something in Notepad, and it looks like it gave me some JSON data, values 1, values 2. So there's a real HTTP service there that's serving up data. All right. Well, where is that service? Let's find it. It's here in this controllers folder, and those values were coming from this values controller class. The way you create a web API with ASP.NET Web API is you derive from API controller. If you're familiar with MVC, when you want to deal with HTML forms, you want to deal with HTML views, you derive from controller, big C controller. If you want to build a web API, you derive from API controller. And it's a tailored experience for building HTTP services. Like you'll notice, for example, that the action methods, the pieces of code that you're exposing for clients to call, are actually pivoted on HTTP verbs. Get, put, post, delete. These are the well-understood concepts in the HTTP protocol, how you get something, how you create something, how you update something. Actions are just the HTTP verbs in Web API by default. If you prefer a more like RPC style pattern where you have action methods like add, subtract, or approve, whatever, you can do that too. You can create a route that has an action parameter very similar to the MVC style. But by default, we'll give you something that's a little bit more resource-centric. You're getting something, you're updating something, you're deleting something, and so forth. And the convention is very simple. The method is prefixed with the HTTP verb that you want to handle. Get, post, put, delete. Okay? Now, that's not a very interesting web API. It's returning some static values. That's not very cool. Let's do something a little bit more involved. I'm going to do add a class. Let's add a model type. Let's call it to-do item.cs. And let's give it some properties following the Entity Framework Code First conventions. Give it a to-do item ID. Let's give it a title. And whoa, I hit an insert key, I guess. Title. There we go. And let's give it a Boolean isDone property. Okay, so I'm going to build that. So there's my model type. I'm going to create a web API that manages to-do items, things that I need to get done. We can add validation logic on top of this model that web API will honor. So I can say, like the, if I spell it right, that the title is required. There we go. Now I'm going to go ahead and create that API controller, the thing that's actually going to manage these to-do instances. To do that, I'm going to right-click on controllers. I'm going to select Add. If you were in an older version of in the current tooling that we have, within an MVC project, you could right-click and say Add Controller or Add View, and there was some cool scaffolding tooling that you could then use to create MVC views and controllers and web API controllers as well. But if you happen to be in like a web forms project, you got nothing. Sorry, that's web forms. That's a different technology. Why would we make the tooling work in both cases? Well, actually, we have now made it work in both cases. We have unified all of the web applications, so they all have the same GUID, and there's one set of scaffolding tooling, ASP.NET scaffolding, that works across all of your web apps. And you can use it to create your MVC controllers. You can use to scaffold web APIs. You can use it to scaffold web forms concepts and so forth. And you can create your own scaffolders if you wanted to and plug them into the system. So I'm going to select Add Scaffold. That's the new tooling entry point. That's going to bring up the new scaffolding system. There's a bunch of stuff here. And there's some future UI enhancements. You can tell, like, there's a search box here that needs to light up and some navigation things. But for now, this is what's there. And you'll see there's a scaffolder for creating a web API to controller with read-write actions using EF. Let's do that. I'm going to click OK. And I'm going to give it a name, to-dos controller. This name of the controller is important because it'll be the name of my resource. It'll show up normally in the URI. Now I'm going to pick the type of data that it's going to expose, my to-do item, and I'm going to store it in a database, so I need a DB context. I'm going to create a new DB context that's going to create it for me. Great. Click OK. This is going to scaffold out for me my web API. I'll give it a second, and poof. There it is. OK. Now what did I get here? Let's take a look. Again, we have a type that derives from API controller, and you see the same action methods that you saw before: get, post, put, delete, because this is HTTP. But there's some cool stuff going on here. Remember I mentioned that web API is an HTTP framework. HTTP is at your fingertips. We use the new modern HTTP programming model that shipped in .NET 4.5. HTTP client had a strongly typed notion of an HTTP request message. That's this guy right here, this request property. But look at that. It is of type HTTP request message, and it has strongly typed notions of headers and of content. It's great. It's beautiful. It's right there. You also have a strongly typed notion of an HTTP response message. You can just return it. You can just accept the request. But we, of course, provide you strongly typed helpers. Like if you want to bind parameters to a specific type, we know how to take data out of the request, deserialize it, understand its format and turn it into types. We know how to serialize data that you put in the response into formats of your choice. So you'll see that we have HTTP concepts right at your fingertips. And in fact, we're even doing things like setting headers. Like here on the response message, I'm saying I want to set the location because this is a post action in this particular situation. A post in HTTP means usually create something. It doesn't have to, but that's a fairly common semantic for post. So when you create something, HTTP says, if you're going to create something, it'd be nice if you told the client where you actually created it. Tell it the URI of that new resource that you created. That's what the location header is for. With Web API, we help you with creating those links. You'll see there's a URL link helper here so that you can create a link to that newly created resource. You'll also notice that the response message that's being constructed right here in this create response call has a specific status code, a tool1 status code, which in HTTP means I created something. So I created something, and here it is. Okay? So let's go ahead and run this and see what this looks like. Oh, shoot. Hold on. Let me stop. I'm going to add a little bit of demo magic to this web API so I can actually send it requests a little bit more easy than I currently have set up. I'm going to add this little simple test client. You can find this on NuGet, actually. You can try it out yourself. I'm going to install this. This will just help illustrate some points. All right. How many people have used NuGet in this room? Raise your hand high. Oh, wow, yes! Yeah, I ask this question regularly, and so many times I'll get like, a third of the people raise their hand. Good job. Yes, NuGet is a fantastic way, the easiest way to get logic into your project. Okay, now so that added just some little tooling for sending requests, and I'm just going to do a little tweak to that tooling right in here, just so that it shows up. We've got to wire it up. So HTML dot display for model. Test client. Dialogues, and then one more for the scripts. Test client references. Okay, that's just some demo. This is just so I can send some requests. All right, we're at F5. It's a little extension to the help page for adding a test client. And let me put it at our URI that actually it'll understand. All right, we're back at our web API landing page. I'm going to go to the help page. And let's see. Let's do a get. Here's I can see you saw the URIs for the to-dos, right? So now I have a to-do controller. It automatically gets picked up by the help page. That's automatic help page generation in action. I can see the sample request and response format. You'll notice that it's in both JSON and in XML. That's because in Web API we support formatters. This notion that a request body and a response body can really contain anything. It can contain binary data. It can contain JSON. It can contain XML. Out of the box, we give you support for XML and JSON, form URL encoded data. And we understand the content type header and the accept header in HTTP so that the client and the server can negotiate what that format is and provide the right content in the request and response. All right, well, let's send a request. I'm going to say get to API/todos. I'm going to let the database wake up, say hello, and I get some JSON back, and it's empty. That's because there's no to-dos yet. Let's go create some to-dos now. All right, so we go back. So to create to-dos, we do a post, correct? All right, I can see, again, sample requests about how I post a to-do. Let's use this little client to help me do that. Let's do, I don't know, get a haircut. I did actually do that already, so I guess I'll believe that one is true. I don't need to share it anymore. Let's send. All right, and then we got a 201 created response. There's that status code. That's the right status code for indicating if the resource was correctly created. And you'll notice there's that location header that's telling me where this new resource is. Do you believe it? Is it there? Let's find out. Let's even do it in Chrome so that you know I'm not like cheating through IE or something. Do we believe it? There it is. Okay, get a haircut. So there's an actual web API call backed by a database. All right, and I can, we don't have to just do it in JSON. We can do it in XML. And that's fine too. To uncreated. Notice that it returned the response in JSON still. It's because the client didn't say what it really wanted. It just said, here's, post this. And the server said, OK. And you didn't tell me what format you wanted in response, so I'm giving you JSON. If the client wanted to say, it can do that. The way it can do that is using the accept header. So the client can say, when you give me a response for this resource, I would really like it as XML this time. OK, so we can send. Let's change this so we know it's a new one. And there you go. You can see the response is now in XML as opposed to JSON. Last thing, I put that model validation attribute on the type. Let's see if that thing's really working. I'm going to delete the title. Let's move it back to JSON because it's just a little easier to read. And let's get rid of this accept header so the response comes back as JSON. And you'll notice now I'm getting 400 bad requests. And that's the standard HTTP way of saying, that request was no good, client, sorry. And it even gives me the reason. It says the request is invalid, the title field is required. OK? So there, hopefully that wets your whistle about what Web API can do. I'm going to stop there and let's go talk about a little bit more about what's new in the framework. Okay, so that's all stuff that mostly has shipped before. I showed you a bunch of the new tooling experiences inside of Visual Studio 2013 preview. That's getting better. But there are also a bunch of new runtime features that we've added in this latest version of the framework. First of all, we've added support for attribute routing. The services that we built with Web API v1, the way you defined your URI space, I didn't actually show this, I'll probably show it when I get back to Visual Studio, is you used ASP.NET routing, just like you would in MVC. You set up routes, and you say, for this URI pattern, if you see a request that matches this URI pattern, then pull this data out of the request URI and call this handler, and it would call the Web API handler if it actually matched. And that was great. But sometimes you want to have your routes live a little bit closer to your resource definition. ASP.NET routing, you have a centralized place where you're listing all your routes. Sometimes you'd like to be able to just put those routes right on your resources, on your web APIs, and we are now able to do that. We are shipping support for OWIN integration. If you're not familiar with OWIN, don't feel bad. Not many people are. But what OWIN is an abstraction for web servers and web apps. It's a way to decouple them so that as long as your app is written against the OWIN abstraction, it can then run on any OWIN-compatible host. And ASP.NET is an OWIN-compatible host, but there are also other interesting OWIN-compatible hosts out there, like we're working on a new lightweight, fast one called Katana that's coming out. We want to be able to work on top of any OWIN host, so Web API now supports OWIN. We have done some work in Web API to make it easier to unit test. We've always had testability as a goal with Web API. Like, there's no dependency in the runtime on any static state. It's all instance state, which is great for testing. But there were some things that were probably a little harder than they needed to be in Web API v1. We've cleaned that up. We've also introduced a new concept, an IHTTP action result, very analogous to action result in MVC, to help you with unit testing so you can package up pre-canned logic and unit test it separately. We support portable Web API client logic now. The Web API client story it's just HTTP, so just send HTTP requests, and you use the new HTTP client in .NET 4.5. There's also a portable version of the HTTP client that works on phone, that works on Windows Store. We add some goodness on top of HTTP client to help you deal with different formats like JSON and XML. You can now take the portable HTTP client with that formatting support, write your client logic once, and then use it across all of your client applications, or even on the server too. If you want to write a formatter that you use on both the server and the client, you can do that by writing portable libraries. Web API supports OData as a format. We shipped some initial support earlier this year in the Visual Studio Update 2, 2012 Update 2. It had some holes in our support. We had some support for queries, some formatting support, but our query support wasn't all there. Like, we supported things like top, skip, order by, but we didn't support things like expand and select. We didn't support batching. We've added those features now. So with this release, we think that Web API OData is actually now a full framework for building out OData services. And I'll show you that. And then lastly, I'm going to talk about Web API security. How can you secure your Web APIs? We're doing a bunch of work in the runtime to allow you to secure your Web APIs using, to authorize requests using OAuth 2. We also have added support for cores, which means that your Web APIs can be available cross-origin in browsers. Normally, browsers can only call back to their point of origin. With core support, it's a standard that allows browsers to make cross-origin calls. We support that now as well. So let's go through some of these features. What is attribute routing? So your routes in Web API v1 would look like this. This is an example of a route you might write using ASP.NET routing. You add a route. It's a long list of imperative code. You have a route template that specifies the structure of the URI, and then you pull out values from that URI. And then we had a controller selector, something that would go pick the type where this request is going to land. And then we had an action selector that would pick which method on that controller to call. And then finally, you would land on your action method. And for the default cases where you're just following the conventions, this worked great. For some cases, this got kind of hard. Like, in this particular request that I have, I wanted to have a request that was a sub-resource. I had a to-dos, but they were a sub-resource of to-do lists. And that, in this case, I'm actually specifying exactly the controller and the action method that I want to handle that. Why am I having to specify that all the way up there when really the method that handles it is all the way in my code? With attribute routing, this gets much better. You can, with one line, you can enable attribute routing. These are still routes. They're still routes that live in ASP.NET routing, the route table. We have a one-liner extension method that will comb through your web APIs and pull out the attributes and add routes to the route table accordingly. But now you can just add an attribute to your action method and say exactly what the route is for that method. You can also do it at the controller level. So here we have the get-to-dos action. It's representing the to-dos resource. And I put the route template right in the HTTP GET attribute. You can do more things, too. The routing syntax in attribute routing has been extended somewhat to make certain other scenarios easier. For example, with a question mark, you can indicate a optional value instead of having to do, a blah equals route parameters.optional, I think is what the syntax was. If you want to specify default values, like an actual value, you can just do that in line inside of the route template. If you want to specify constraints, with routing, you can specify constraints today, but it means implementing a class and adding it to the route. You can now add what are normally common constraints inline directly in your route templates. For example, here is 2 examples where I want to actually dispatch a request by type. If that ID parameter, if that last segment in the URI is a numerical, then I want to call one method. If it's letters, a word like Dan, then I want to call a different method. That wasn't really, it was hard to do that before. Now it's super, super easy. Well, let me show you how easy it is. Okay, I've got some controllers here, and they use attribute routing. Now, remember, to turn this on, I did have to add a line of code to my config. This is it, config.map HTTP attribute routes. And that will go find all the routes and add them to the route table. So it's still routing. You can compose other routes with your attribute routes. That works just fine. They just get added in whatever order you decided to call this method in relative to adding the other routes. All right, so here's some example scenarios that are now much easier using attribute routing. Here I have an orders controller. In this case, I have some resource-centric actions, get, post, put, delete. But sometimes I just want to have one, let me have one little RPC-centric action. I want to have like an approve. It's kind of a post, but it's my own custom action, but I still want it. Can I have that with my other actions too? With Web API v1, people would try and do this, and they would get in all sorts of trouble because the action selector would get confused and would say, there's 2 post actions here. I don't know which one to call. Now it's much easier. You can make it very, very clear. This is an orders resource. Here is the action that will handle creating orders, and here's the one that actually approves them. I put the route right on the action. Let's run this and actually see that it works. In this case, I've already wired up the little test client, so I don't have to do that again. All right, let's go to the help page. Okay, where's orders? There's orders. So let's post an order. Test. Okay, order 1, sure, that looks great. So I'm going to send that. You'll see, boom, I'm hitting the first action. That's the right one, because all I did was send a post request to orders. Now if I send it to orders/1, say, approve, I expect it to go to that second action on the same controller, and it works. These are both post actions, but it's able to differentiate through attribute routing. That's nice. Let's look at another scenario. Okay, sometimes you want to version your controllers. Like here I have 2 versions of the same web API. Turns out, I made some design decisions about the structure of my data in v1 that didn't pan out. I was using like integers, for example, for my customer IDs. I decided later that I want to use GUIDs or something like that. There are a bunch of strategies for versioning your web APIs. You can use a custom header. You can use media types. But one strategy when you've really completely changed things and you actually have different resources is you just change the URI. Here I can use this route prefix URI to say that this resource, every request to this resource is prefixed by this URI space. So here I'm saying this is v1 of customers, this is v2 of customers. Let's see that actually working. So if I go to v1, issue a get, there's getting hit. And I get customers with an integer ID. If I go to v2, I'll just change it right here. I'm getting the second one with the v2 with a GUID. And I can see that in the response. So that's sort of a versioning using attribute routing. Let's look at one more scenario with hierarchies of resources. So here's a controller that's representing a list of movies. And in Web API v1, it was very much one resource per controller. That was really the idea. But often it's convenient to represent multiple resources on the same controller. Here I'm representing movies, but I'm also representing the movies that a particular actor was in, or movies that were directed by a particular director. And I can just have action methods on the same controller that handle those different resources, and I just do that using attribute routes. So movies, actor slash, you can put route variables in these things, and they get picked up. And here's movies for the directors. Let's see that working. Let's see, movies, let's do, actually, we'll do the first one. All right. Movies, get all the movies. There it is getting hit. So there's all movies. You see that down there. If I change this now to be actor slash one, say movies. Give me all the movies for this particular actor. There's the actor action getting hit. And that just works perfectly. And then lastly, directors. So here's multiple resources and resource hierarchies being represented on the same controller. All right, and then last one is using routing constraints. I showed this example in this slide previously. Sometimes you want to route to one action if the structure of a particular path segment looks a particular way, like me or people slash Dan versus people slash 123, where 123 is the ID of a person, whereas if it's Dan, it's actually their name. I want to be able to look them up by name or by ID. You can do that now using constraints, and there's a whole bunch of them. Here's an integer constraint. Alpha would be letters constraint. You can even define your own. Let me show this working. So people 1, 2, 3, or 1, 3, 2, whatever, that goes to the first action. But if instead I specify a path segment that is just letters, like Dan, then I get to the second action. Cool. That's attribute routing. Oh, applause, yes. Glad you like it. So for all of you who miss URI templates from WCF, something to go. Why isn't this thing working? Whoa. Oh, yeah. So this feature actually was a contribution from the community. Tim McCall of AttributeRouting.net fame. He had written attribute routing support for MVC. He was working on it for Web API. We saw what he did. We liked it. And we said, hey, Tim, why don't you just work with us? We can take what you did and bring it right into the framework. And so we worked with our devs. We iterated on the design. Because he was right there in the core, we could do things like integrate really tightly with the Web API runtime, which was great. So thank you, Tim. And we look forward to more contributions from folks. All right, let's talk about unit testing. So unit testing of Web APIs was certainly possible, but in some cases it was harder than you would have liked, particularly for actions like that post action where you're doing, actually doing a bunch of really tricky things. In that post action, you were getting a request from the user, and then you were creating a new resource, and then you wanted to set the location header on it. So that meant you had to actually run content negotiation all in your action. You had to pick the formatter in the action method, set the header, and return a response message. And that meant you had to know what the formatters were. You had to put config on some crazy property on the request message. It was pretty ugly. We've gone through and cleaned it up, though. So hopefully it's better now. Now the pattern is you can just create your controller. You can set properties on it, whatever you need. You can set a request. You can set your configuration as much as you need. And then you just call the action, and it just works. We've also introduced this new concept, IHP action result, so that you can package up the results of your action. Like if you were, imagine a created result, for example, that represents the created resource and its location header in a single instance. You can then unit test that IHP action implementation separately, and then just verify on your action when you're unit testing the action that the properties on that IHP action result are what you expect. Very similar to the MVC pattern. All right, and the way ASP action result works is you can just return it from your Web API actions. They execute immediately, and when they execute, they just produce an HTTP response message. And then from that, then on, throughout the rest of the Web API pipeline, the rest of the artifacts all see the response message, like action filters and authorization filters, message handlers, and so forth. So let's take a look at what unit testing looks like now in Web API. All the way down here. All right. So here I have a Web API. This is basically that same Web API that we just built earlier. Some little tweaks. I had to make some little tweaks, I'll admit. So the main tweaks I had to make were because I needed to be able to mock out the DB context, the database access. When we scaffold out your Web APIs, we scaffold the DB context directly into your code. Some people actually prefer to do a repository pattern where you have an interface that you're actually dealing with. Scaffolders don't currently do that by default. So in order to mock out that database access, I just created an interface for the DB context in order to allow that to be possible, where I can create an in-memory context to stub out the database. So just a little tweak is all I did to the controller. Other than that, it looks pretty much exactly the same. Get, post, put, delete. Here's that post action. You notice the logic looks just the same as before. You're creating the response message and setting a location header. That's the one we're going to test. Let's test this post action and see that it's actually working. All right, so I have this unit test project. And let's look at what the unit test looks like. Here it is. OK. Now remember what I said before. The way you can now unit test your Web API is you can just create the controller, set the properties that are needed, and call it. Here is me stubbing out the database. So I created a fake to-dos context, a fake DB context that just has the data in memory. I create my Web API controller. There's the to-dos controller, and I added a constructor so I could inject that fake DB context. If you're using IOC, that's cool too. I was just trying to keep things simple with as few moving parts as possible. And then I just set the properties that I need. I'm going to add a request message. And this setup config is just grabbing. What all this is doing is we factored your Web API configuration so that you can new up a configuration instance and just pass it to the logic that sets it up. So this is an easy way in your tests. If you want to, in order to get the config object, just new one up, pass it to your Web API config.register method, and it'll create it. It's very similar to how you would unit test your routes in MVC using the register routes method. All right? So provide your config. Now, I'm also setting route data on this request. Why am I doing that? That's because the route data is going to be used for doing link generation. Now, there's actually two ways to do this. You could either provide the route data directly, or if you wanted to mock out the helper, the URL helper, for generating the links directly yourself, you can do that too. Both things are possible. In this case, I just decided to provide the route data directly. And then you just call the Web API, so controller.post actions. Okay? And then you can validate the results. Here I'm validating a couple things. I'm validating that the header on the response, the location, is equal to what I expect. And then I'm also validating that the body is a to-do item and that the ID of the to-do item is what I expect it to be. Okay? So we can, I think, run this. And because I'm a PM, you can tell I do unit testing all the time. And VS, for some reason, is not finding my tests. Wake up. Where is it? I need to build, it says. That's right, build. OK, I built. You see the build succeeded. I did build. All right, let's try it again. Team, no, test, Windows, Team Explorer. Show up. Alt S? What's that do? Well, these are preview bits. I don't know. Maybe Test Explorer is having a little bit of issue finding the test. I did show up earlier. I did have this problem as well. But hopefully at least you can see what the code looks like. This code does actually run, and it does actually pass. Try it yourself, and you'll see. But you create a new controller, you just set the properties you need, and you're done. You don't need to go messing around with HTTP request message dot properties with crazy keys and setting config in random spots. All right. Now, what if I wanted to use IHP action result? Let me show you just quickly what that would look like. If I go back to the controller implementation, I'm just going to hack it a little bit. Okay. So instead of returning HTTP response message like it is now, I could instead return IHP action result. All right. It's a perfectly valid thing to do, and it's a very simple interface. All it does is execute, and it returns a response. Does that make sense? Okay, so I could change this method in implementation now, that instead of doing some of the things that are in here, let's see. We could do ignore. I would need a new constant result for the location header, so I'm going to ignore that for now. Let's do this and say instead of. So I can return content. And just return the to-do item. This content method is a helper method that's on the API controller. What do you say? Oh, I forgot the status code. Is that what? Yes. I'm going to say HTTP status code dot created, and then the item I want to return. So here I have, in one method, I'm creating an IHP action result that encapsulates that notion of, first of all, here's the thing that's going to go in the body, and it's an object right now. Please select a formatter so that it actually gets serialized as whatever the client wants. Encapsulates that piece, and it's also encapsulating the piece that the status code should be 201 created. And so you can now separately unit test this content action result, make sure that it's working, and then when you call the action method, you just validate that the status code was set correctly and that the object you meant to be set is set as correctly, and you're done. So that can also simplify your unit testing as well. So that's IHP action result. All right. Okay, let's look at what OWYN integration looks like. Web API has always supported more than just ASP.NET as a host. We've supported what we've called it self-hosting, where you could create your own process. You could host a web API within that process, and you could be in a worker role. You could be in a Windows service, wherever you wanted. You could also host in ASP.NET, which is a great place to host things. The self-host story that we shipped in V1 was actually based on a tiny little sliver of WCF. And that was just so that we had a piece that could manage the HTTP listener for us. And it was Web API specific. That thing was only good for hosting Web APIs. That's what it did. OWYN is this abstraction that specifies how HTTP servers and web apps should interact. And by supporting OWYN as an abstraction, you can then have your framework, your application that uses an OWYN-enabled framework, live on any OWYN-based host. ASP.NET is now a fully integrated OWYN-based host. We've integrated OWYN very deeply in this release into the ASP.NET pipeline. In between your server and your app, you can actually stick middleware, like pieces that like a pipeline that the requests can flow up and down through, and you can do things in that pipeline like handle authentication or other concerns, logging, and it sits in the middle, and it's deeply integrated into ASP.NET so that you can actually have middleware run at the right stage in the ASP.NET pipeline. Like if you have middleware that's doing authentication, you can register it in a way that it will actually run during the authenticate stage of the ASP.NET pipeline, which means that even frameworks that aren't OWYN aware at all, like web forms or MVC, can still take advantage of things like OWYN middleware components. And those OWYN middleware components can then work not only in ASP.NET, but they can work on any OWYN-based host, like the new Katana host that if you're following the Katana project that we've been working on. There are several OWYN-based frameworks out there already. If you're familiar with SignalR, SignalR works on OWYN. I believe Nancy currently also supports OWYN, if you're familiar with the Nancy framework, some other third-party frameworks that support it. And this means that any of these OWYN-based frameworks can now happily sit side by side, not only in ASP.NET, but also on top of any host that you'd like. So I'd like to show you what the new OWYN-based hosting story for Web API looks like. Okay, so this is a console application, and it's going to host it hosts a web API. Here's the program, that CS file, and here's where it's firing up Owen. You know, constructing, you're telling the Owen host where to go find the middleware to put into the Owen pipeline. And it's saying it's the Owen pipeline is configured by this startup class. And that's a normal convention. If you're dealing with Owen, you'll have a startup.cs file that has a method that configures your middleware pipeline. So here's my startup.cs file. It's very simple. It's just a configuration method. That's the convention, and it takes this app builder thing. That's what you use to set up your pipeline. And all I'm doing is I'm saying I would like to use Web API, and here's my config, and that I've already set up. In this case, I'm just going to use attribute routes, and then I'm just going to use the default configuration for everything else. Here's my controller. It's just a normal values controller that I've set up with attribute routing. And that's it. The listener address is specified up here, so this is where the Owen host will start listening for requests. And in this case, in my startup file, all I have is Web API, but I could just as easily have added things like SignalR or Nancy all within the same application. So if we look at program.cs, after starting up the host and listening, it's also going to new up an HTTP client. That's that new, beautiful, modern HTTP client programming model, and use it to send a request to the service and then print the response. And then it's just going to pause. So let's run it and see if it does it. And boom, there's a 200 OK from the HTTP client to show you that this is actually listening and serving responses to requests. Let me go ahead and again fire up the other browser and send a request to that address. And there you see that it's actually responding. So that is our Owen-based host. So you can do host Web API this way, where you're basically creating your own host. We have the Katana pre-canned host. It's just an exe that discovers startup.cs startup classes that can run them for you. Or you can, if you want to, you can host Web API inside of ASP.NET using this mechanism. Currently, we're still using our web host integration where we plug right into ASP.NET routing. But I imagine at some point in the future, probably we'll just say, the way we hook into a host is using Owen. So that's what that looks like. So if you're using, how many people are using the self-host for Web API? See some hands over there, a couple, okay. And that's great, it's supported, continue to be there forever. We are moving towards Owen as being our hosting strategy. So I wouldn't expect, like huge, awesome new features showing up in the WCF self-host in the future, but it is there and you can continue to use it. But just so you know. All right. Let's talk about OData. Like I said, we've shipped OData support in Visual Studio Update 2. It had some limited, I would say, support for OData. Rich, but limited. We had ability to support the XML, Atom, and JSON-based formats for OData. We provided you model builders so you could set up your EDM, your entity data model for your OData service. We gave you parsers for dealing with the OData path and the OData query so that we could understand what the request was for based off of your model. We gave you pieces that could take that parsed query and turn it into a link expression and then apply it to an iQueryable so that you could actually take a request that had a query on it and plumb it all the way down to even to your database, depending on which query provider you're using, so that you can have rich query semantics for your web APIs. The query semantics that we supported in that first rev of Web API OData was basically top, skip, order by, and filter. And we have now added support for select, expand, and we also support batching using the $batch semantics. The batching semantics actually is generic. $batch is just one instance of the request batching support in Web API. You can plug in your own batching semantics as well if you'd like. The underpinnings of Web API OData is OData lib. OData lib is built by the Microsoft OData team, and it's the sort of like the XML infoset layer for OData of abstraction. It's the same underpinnings as what's used by WCF data services. So Web API OData is built on an industry strength, OData stack. It is the real deal. So let me show you what the new $select and $expand support looks like. Okay. So here I have a project that has, let me show you the model for this. Can you see? Yes, you can see. Great. So I have this particular Web API has customers, and customers have orders, and orders have order details. Okay? And order details has some data on it. So this is data with relationships. the customers have orders, and orders have order lines, and you want to be able to sometimes navigate those relationships. Sometimes you want just the customers, and you just want to know, like, where do I go find their orders? Just give me a link. So other times you say, I want the customers, and I need everything about them. Give me their orders and their order lines, because I'm going to process all that data right now. And OData helps you do things like that. It also gives you a rich query language over that data model, so you can say, I want just these customers, not those. Or I want just the customers that have these particular kinds of orders, not the other ones, and so forth. $select and $expand specifically allows you to specify how much data you want. Select says, I want the customers, but I only want these fields. Like, I just want their name, or I just want their age. I don't want anything else. Everything else you can keep. Let's save some electrons and some bandwidth and battery power by limiting how much data you actually need to request. Expand is where you say, I want the customers, and also please expand their orders. Give me everything at the same time. Don't just give me links. I want the whole deal, because I don't want to have to go back and make another request. That's also, again, a pattern that's more efficient. And the way you enable support for $select, $expand, and all the other OData query semantics in Web API is just by adding this attribute. There it is. So here's my get action. I'm returning a collection of customers, which is going against the database, and then I'm saying I would like this thing to be queryable. And you get the rest. And you have ability to control how much query this queryable attribute is going to expose. Like if you want to go in here and you want to say things like, I only allow you to order by name, or I only allow these particular options. You can do that. And one of the nice things about Web API and OData is you can bring as much query semantics to the table as you want. Because, this is your database. You're going to want to protect it. You don't necessarily want to allow willy-nilly queries against your database. We give you full support for query validation. But for now, I'm going to keep things simple and just allow you to do whatever. All right, let's run it. Okay, this is a self-hosted OData service. So this is actually just running in a console application. Pop up a browser so we can fiddle with it. That looks good. Let's get the customers. And the database has got to wake up. Oh, you want me to serve some data? Just give me a second here. Let me find it for you. Come on. Oh, there it is. Okay, so you can see, can you see that? I don't know if I can zoom it. Does Control Shift this thing? No. Does anyone know the zoom operation in Chrome? Control what? Control plus. Thank you. Control Shift this guy. Oh, yeah. Is that better? Okay. So you see I've got some customers, and the customers have an ID, and they have a name. But let's say I only want to have their name. So I'm going to say select with a query, select their name, and poof, the IDs disappear, and I'm only getting their names. All right, that's cool. That's select. Let me say, no, I want to actually expand. I want more data. I don't want just the customers. I also want their orders. And boom, instead of just getting the customers, I now have an orders property that shows up with all the orders for those customers. And you can nest. You can say things. I don't just want their orders. I also please expand their order items. So you get their orders and the order items for all the orders in one single request. And these things compose. If I want to say, I want, please expand all the data, but the only things I really care about, even in the expanded data, is I only want the name and I want the purchase date for the order items. You can do that and then filter down the data. Okay? So that's select and expand. And those queries are actually all going against the database, and it's all just enabled by attributing your action method. So OData, pretty powerful stuff, hopefully pretty useful. Cool. Hey, thanks. We've got to move. We've got so much stuff to get through. Okay, let's talk about Web API security. This is not security is never a simple topic, so forgive me. This may seem like, this comes a little fast. So you can feel free to come ask me questions afterwards. It's taken us a while also to get our heads around security problems in this space. Here's an application. Maybe you found this application on your phone. It's a great app. It says, actually, I lost my. I had some edits on there. The title of this app is actually supposed to be Free Facebook Friends. Free Facebook Friends. Where is it? Oh, I can't edit it now. So it looks like it's a Facebook app, right? It looks kind of trustworthy. And it has this thing at the bottom that says, please give me your password. I apologize. Imagine this is not the official Facebook app. This is just something that looks like the Facebook app, and it's asking you to give it your credentials. Would you trust this app? Would you give it your credentials? these type of apps need to do web API calls in order to access data that the user owns, protected resources for the user. What is the right way to do that so that you don't have to give the app the key to your house so they can do whatever they want, eat all the food out of your fridge? How do you do that? There are a bunch of challenges actually in the web API security space. You may not want to trust the client apps with your full credentials. Actually, apps in general also generally don't want to have to handle your credentials. That's a liability on there. They have to figure out where to store it. They have to make sure they don't lose it. They don't want to be dealing with such sensitive things like the user's credentials. Many servers don't want to have to store passwords either. They'd rather just delegate identity to someone else. How can you have a web API call where the identity of the user is actually being managed someplace else? How do you do that? Client apps access to protected resources ideally should be scoped. Like, I'm going to give this, it'd be nice if I could give someone access to just, the furnace in my house and not the whole thing. Like, it'd be nice if I didn't give them the key to the whole thing. I could just give them a code that let them get access to the furnace. You know what I mean? You should be able to give scoped access to your protected resources. We want to support a variety of clients, including browsers. That means we need to be able to support cross-origin. We do support CORS now in Web API with this preview release. When we support browsers, though, what do you do with browsers often for security? You use things like cookies, right? Cookies serve the forms off. That's how you normally do with a web app. You post a form with a username and password. You get back a cookie, and then you're good to go. You just make requests with that cookie. Unfortunately, browsers will forward that cookie all over the place. Like, if you download some code from a malicious site and that code tries to make requests to your stuff, the cookie will just go with it. And so normally website authors have to do things to prevent request forgery. And for web API calls, like on a native app, that starts to sound a little clunky. I don't want to have to be dealing with cookies and dealing with anti-request forgery tokens when I'm running a Windows Phone app. I'd like to do something simpler. So we need a friendly approach for native and mobile applications. Cookies probably not the best approach. This is not Cookie Monster. This is Veggie Monster. They made me change it to green, which I thought was awesome. All right. So what are we going to do? The approach that we're taking is we are going to leverage OAuth 2. And the auth in this case actually refers to authorization. OAuth 2 is a framework. It has some protocol aspects to it, but it's actually a protocol framework, I guess is the way we call it, for authorizing client applications to get access to users' protected resources. It's a standard. There's the RFCs. And it's designed specifically to work with HTTP services. You use OAuth 2 so that a client app can access some resource, which is a web API call. That protected resource almost always is represented by some HTTP resource that you can get or modify. It's not actually an authentication protocol. It's not used for authentication. It describes places where it does need to authenticate the user or even maybe authenticate the client app. But how that's done is completely up to you. You could use a forum post. You could use, OpenID, whatever authentication mechanism makes sense. But it is specifically designed for authorizing client app calls to protected resources. And there are multiple flows that it defines for different types of clients, whether you're talking a browser client or a native client or a server-side flow. And this is kind of what it looks like. You have your client app, and you have these three other roles. There's the resource owner, that's the user. Then you have the authorization server, and the authorization server is what's going to actually grant limited credentials to the client app to access the user's stuff. And then you have the actual web API, the resource server. And the client asks the user, I would like to access your photos. Would that be OK? That's called the authorization request. User, can I access your photos? Sure. OK, maybe you've seen this. Like, you go to a Facebook app and you log into the Facebook app and it says, this particular app would like to access your email address. Is that OK? And it says, yeah, it's fine. So then the client app has a proof now that the user has authorized it to access your stuff. And it can now go to what is called an authorization server to get an access token. And that's the credential it will be able to use to actually get the photo. So the app goes to the authorization server and says, here's proof that the user has authorized me to access their photos. Please give me a token that I can use to do that. And the authorization server looks at that token, validates it, and says, OK, here you go. Here's the access token that you can now use. And then finally, you use that access token to go access the protected resource. Okay? Now, the clever part of OAuth is, how does that authorization flow actually occur? How can the client app ask the user in a reasonable way to give it permission to access the user's protected resources? And the way that's done is through some cleverness, through some redirecting. There's a couple ways, actually, that it can be done, but this is sort of the classic flow that I'll just quickly describe. So the way it works is the client app actually redirects the user's user agent, their browser. It does a 302, so that the user is now bounced over to the authorization server. And in that redirect, the client asks for a particular scope of access to the user's resources. And it tells the user, this is my ID. I want to access this scope of your stuff. Please get me some proof that you allow me to do that. So the user gets bounced over to the authorization server, and the authorization server looks at the client's request and says, user, first of all, who are you? And that's where authentication occurs. Once the user is authenticated, the authorization server says, this client app with this ID would like to access these things. Is that okay? The user can then say yes or no. If the user says yes, the authorization server then grants an authorization code, and it gets bounced back through the client's browser back to the client. And that's what the client can then use to prove that it has authorization from the user. It's a one-time use token, but it's now got proof. From that point on, the user's out of the picture. They gave permission, we're done. And then the client can go to the authorization server's token endpoint and exchange that authorization code for an access token. And optionally also a refresh token, because that access token can expire. That's one of the nice things about this token-based approach. That access token is scoped, and it can be short-lived. With that access token, the client can then make requests for the protected resources. That's your web API call. And it's done by passing the access token in a standardized way using an authorization header as a bearer token. There's actually one of the two specs for OAuth 2 is the OAuth 2 framework bearer token spec. And that just says this is how you can pass an access token. It doesn't say what the access token should look like, but it says this is how you can pass it. And if the access token looks good, then the protected resource can be accessed. And then, of course, there's a flow for refreshing the token if it were to expire or the client wants a different scope of access. OK? So then we need two things here to protect your web APIs. One is you need to secure your protected resources. That means you want to accept bearer tokens, OAuth 2 bearer tokens that are valid. And if they're not valid, then the request doesn't go through. That seems pretty simple. And we are providing support for you to do that. We are shipping OWIN middleware that handles OAuth 2 bearer tokens. Bearer token middleware, I guess is what I should call it. I don't know. We don't have a great name for it. That's what it is. And what this means is that the client, if it sends a request, if it doesn't have a good bearer token, then it gets rejected. If the client sends a request with a bearer token, then you're good to go. Now, that's great. So now your web API is secure, and it's one line of code. You just, in your startup file, you say, use OAuth bearer authentication. You pass some options to say how the token should be validated, and you're done. Your web API is secured. Well, OK, but now how do clients actually get a token? How can they get a valid token so they can access your web API? Well, that's where you need an authorization server. And there are two options here for authorization servers that we're looking at. One is that you can host your own. In our templates, in particularly the SPA template, the single-page application template in the 2013 preview, we provide a in-template implementation of a simple authorization server that the client can then use to get tokens to access the web API. We are also working on moving that code into framework code, into actual OWIN middleware for implementing the authorization server role. You can also use an existing authorization server, like Windows Azure Active Directory actually provides a full authorization server and directory that you can just use. You can configure your web API to accept tokens from Windows Azure Active Directory. And we are working on that as well. We actually plan to have that tooled into the experience. We have runtime bits that currently allow you to do that, but it's still currently a work in progress. Active Directory Federation Services is also an on-premise solution where you can have a authorization server that can issue tokens. And you could choose to trust tokens from it as well in Windows Server 2012 R2 specifically, because it supports OAuth 2. All right, and I am like over time. So let me show you real fast what security looks like, and then I'll be done. OK. Real quick, I know I'm over time, but this is cool, so I'm going to show it to you. OK, here is a project that has 5 projects in it. One is a single-page application, and this contains my authorization server. And I actually have a prototype of it done in middleware that's configured in this application. If I look in my startup.cs, you'll see there's that use OAuth bearer authentication middleware. That's protecting my web APIs. But I also have this use OAuth authorization server middleware that's implementing that token endpoint and the authorization endpoint. Okay, that's going to handle granting authorization requests and also issuing tokens to my clients. And so in the SPA application, this is actually an application that's hosted up on Windows Azure. If you look at it, fast, go. Okay, here it is. So I can do username, password. Now there's a flow actually in OAuth that says the client can collect your credentials directly as a way of getting your authorization, and then it can exchange it immediately for a token. That's actually what happens here when I click login with a username and password. The SPA, the JavaScript, is saying, here's the username and password, please give me a token, and then it doesn't have to remember the username and password again. So it's still better, right, than it just having to hold on to your password. So that worked. You can also do the standard flow that I showed before. Here, the authorization server is going to authenticate the user using OpenID, in this case, Google. So this is actually a user talking to the authorization server. It authenticates the user, which is implicitly granting the client access to its stuff. And then the JavaScript gets a token that it can then use to make requests to the web API. And that's what's happening there. This is all just JavaScript talking to a backend web API. That same JavaScript, that same web API is also being accessed here by a Windows Phone app using an OAuth 2 flow. In this case, it's using that flow where it's getting the code and then going to get a token. We can do, or using the username and password. Let's do the one with Google since that's more fun. Let's see if it's going to work. Yeah, I was already logged in, so it just worked. That's not nearly as interesting. Let me do the Windows Store one, because I know I'm out of time. There's Notepad. That was the Notepad demo. All right, debug. Here's Windows Store. Again, this is XAML, C#, but it's going to do again an OAuth 2 flow in order to log the user in. So we can, in this case, the browser, there's always a user agent involved here, right? In this case, the browser is actually the web authentication broker, which is a component in Windows 8 that's like a sandbox browser that native applications can use in order to navigate an OAuth 2 flow. So here I'm going to do, again, log in. And I can see my data again. Okay? So that's 3 applications that are accessing the same web API using the same security mechanism, which in this case is OAuth 2. All right, let's wrap up. There you saw it. Oh, and by the way, those client apps, the Windows Store app, Windows Phone app, we're using a portable library for all the web API access. We now support portable libraries for our HP client and also all the client web API pieces. So what's new in Web API 2? Attribute routing, OAuth integration, security, these new OData features. I hope you liked what you saw. Please give us feedback. Check out the Coplex site. Also, you can find out more docs and get the bits at our ASP.NET site, ASP.NET/vnext, and ASP.NET/Web API. Thank you so much for coming. Sorry I kept you long. I'm happy to stick around and answer questions somewhere over there.